let's go ahead and start with square root functions. The parent function for a square root is f of x equals the square root of x. All right. So to start, we're gonna use a table to graph this. So here is my table. Now, this is a square root function, right? This x inside the square root can be 0, correct? You can have the square root of 0. Can you have the square root of a negative number? No. So automatically, you know that the domain doesn't include any negative numbers. So when I'm picking values for x here, I know that I can pick 0 or I can pick any positive values, but no negative ones, okay? And of course, I always want to work, efficiently, like work smart, not hard. So, 0 should always be a value you look at. So root 0 would be 0. And then 1 is a good number. Root 1 is 1. And for the next ones, I would prefer to pick perfect squares so I can take a square root of them, right? So 4 would be the next one. Root 4 is equal to 2. So I go here, 0. At 1, it's 1. At 4, it's 2. And that's how that continues this way. There is a bit of a curve, okay? And you can gauge how to make that curve because at 9, this is just going to be reaching 3, right? So it's going to be going this way. Okay, as we already mentioned, the domain is x is greater than or equal to 0 because in the radicand, inside the radical, you cannot have any negative number. Once we graph, you realize that the range is also y is greater than or equal to 0. So let's think about it. If the range is the y values, the smaller number I put in here will be 0, and the y value will be 0. Then, as the numbers I put into the square root increase, the y values are also going to increase. And if I put, let's say, x equal to like 120 trillion, then y will also be a large positive number, right? So it could go on infinite to infinity. Okay. Transformations. Transformations work the same way for any type of function, right? So if you have the square root of x plus h, that plus h moves the graph where?
Left h.
To the left h unit. What about if you have x minus h? Right h units. What about plus k outside? Up k units and minus k? Down k units. Okay. If you have a negative outside, this is a reflection around the x-axis. Okay, so for example, if you have your x and y axis, instead of the graph looking, the way we just drew it, it will have reflected, so it would look like this. Okay, now, if you have a negative x inside the absolute value, now that is interesting, isn't it? Okay, so now if I have y equals negative x, the square root of negative x, now can I plug in positive values for x? No. Can I plug in 0 for x? Yeah. Can I plug in any negative numbers for x? Yes. So this will only exist for the negative numbers. That's how it's a reflection around the y-axis. So this will be a reflection around the y-axis. And when you graph it, take a look at how this will look. Instead of going to the right, it will now go to the left in the same way. Do you see that? Right? Isn't that cool? Right? So now we finally can have some meaning to what reflection around the x-axis means. Until now, everything we were doing were like symmetric functions and it really didn't matter, but now it matters. Okay, if you have a coefficient outside, if the coefficient is greater than 1, if the absolute value of the coefficient is greater than 1, this is a vertical stretch. If it's between 0 and 1, it's a vertical, compression. And then here, for both of these, we're just going to call them a horizontal dilation. I don't need you to specify one or the other. Okay. So it was easy when we just had the square root of x. But what if you have the square root of a more complicated expression? To find the domain of a square root function, you take the radicand. What is that word? Radicand? Do you guys know what that word radicand? It's the stuff inside the radical, right? You set the radicand greater than or equal to 0 and solve for x. That would be your domain. Okay, the range. The range has to do with the vertical translation. Does it move up or down? Okay? If a is positive, y is greater than or equal to k. If a is negative, y is less than or equal to k. Please do not attempt to memorize any of this. I hate when students memorize stuff in math. I would rather you just understand and learn. And we're going to do several examples and you'll reason it out right now, okay? All right, so let's take a look at this for a minute. I'm going to show you a couple of ways to do this, all right? So first, I have f of x is equal to the square root of x minus 2. Why don't we first try making a chart? Okay, so first of all, what has happened to what transformations have been applied to this function? To the right 2 units. So where is it even going to, where is that first point? 2. At x equals 2. So that's the first point I put in here. And x is 0. Okay? I'm sorry, y is 0. Next, I want to put a number for x that when I put it in here, the result will be a perfect square. So for example, if I put 3 minus 2 is 1, that's a perfect square, so I can use that and I get a 1. The next number, for instance, if I put a 4 minus 2 is 2, root 2 is not an integer, so I skip it. And what's the next available one? 6, because if I put in a 6 minus 2 gives me 4, which is a perfect square, so I get a 2. So at x equals 2, it's 0, 3, it's 1, 6, it's 2, and right there. Okay, to find the domain, you should be able to find the domain without even having graphed. What you do is you take this x minus 2 and say it's greater than or equal to 0. X is greater than or equal to 2. This is the domain. Now, is there a vertical shift here? No. So it starts at y equals 0. The range will be y is greater than or equal to 0. Okay? All right. Let's take a look at the next one. Let's do domain and range first. Domain. We take x minus 4 and say it has to be greater than or equal to 0. So x is greater than or equal to 4. Right? Now, the range. Is there a vertical shift here? 3. So this is going to start at 3. Now we have to decide, is this function going to, once it starts at 3, is it going to go upward or downward? How do you know? Because it's positive in front of the root. So y is greater than or equal to 3. Okay, now, guess what? I'm going to graph this, but without making a table. Here's what we're going to do. So the first point of this is it has moved to the right 4 and up 3, so it's right there, correct? Now, do you remember how we used to do parabolas? We used to say if you go over 1, you go up 1 squared. And if you go over 2, you go up 2 squared. We're going to do the same thing, but now taking the square root. So if I go over 1, how much do I go up? Root 1, which is 1. Now, I'm not going to go over 2, but if I go over 4, I go up how much? 2. If I go over 4 units, 1, 2, 3, 4, I go up 2. So do you see how much quicker that is to graph like that? Did that work for this one? If I went over 1, I go up 1. If I went over 1, 2, 3, 4, I go up 2. You see that? And if we look at the very, very first one we did, if I go over 9 units, I would go up 3 units. Okay, so that's where that would be. Okay, let's do this one. Oh, I forgot that I had a space here for the domain. So x is greater than or equal to 2, y is greater than or equal to 0. All right, here. What is the domain? X minus 5 greater than or equal to 0. X is greater than or equal to 5. Range. It's y. Okay, there is no vertical shift, so it's going to be 0. Greater than or less than or equal to? Greater than, because it's positive. Okay, now, so I'm going to start from here, 5. Okay, now, when I go over 1, typically I should go up 1, but now it's being multiplied by 3, so I'm going to go up how many instead? 3. And when I go over 4, I should have gone up 2, but now I'm going to go up 6. Okay, so do you see how much of a vertical stretch that is? Okay, Connor, question? Oh, the internet question. Okay. All right, so next one. Okay, what's the domain for the next one?
-4.
Right, but what's the domain?
Oh, the domain is greater than or equal to -4.
X is greater than or equal to -4. Okay, range, it's y. There is a vertical shift of -6, right? But because it's a negative square root, now it's going to go below, so it's going to be less than or equal to -6. Okay, so the end point for this one is going to be at -4, comma -6. Now, when I go over 1 unit, which way am I going to go on the y? Down 1. When I go over 4 units, where am I going to go vertically? Down 2. Okay? Now, what if all this is like so confusing for you and you're like, oh my gosh, there's no way I'm ever going to be able to do this. Plug in points, right? Make a table. The first point you're going to put in is -4, right? And that will give you -6. Hang on. Then put in -3. When you put in -3, you get negative square root 1 minus 6 minus 7. Okay? And you can do it that way. All right.
How come that you went down to 8 to 9 instead of 8 on the y?
It should be 8. Okay. All right. Questions? Okay. Right. So take a look at this one. For domain, I'm going to do 2x plus 1 greater than or equal to 0. 2x is greater than or equal to -1. X is greater than or equal to -1/2. So the translation for this is actually -1/2 units. It's right there. Okay? Y is less than or equal to 0, right? It's going down. Okay. So you know what? For this one, I'm just going to make a table. When x is 0, I get negative the square root of 1, negative 1. And then what number can I put to get a perfect square in the radicand? 4, right? 4, I get negative 8 plus 1, 9. This is negative 3. So when x is 4, negative 3. That way I'm not dealing with like halves and stuff. All right? Okay. Okay. Let's do another one. Okay, let's do the next one. Go ahead and quickly write down the domain and range. So, okay. So if you're walking down the street and you just happen to see that equation on a billboard, just by looking at it, you should be able to figure out what the domain and range are. Okay? So, what is the domain? Greater than or equal to negative 4. And the range? Yep. Okay. Now, where is the end point for this? Negative 4 comma negative 6. So if I go over 1, I go up 1. If I go over 4, I go up 2. If I go over 9 to positive 5, I go up how much? 3. Right? If you want to put like more points over there. Okay? No. Just showing you guys the pattern, yeah. Okay. Well, you know, those are like fun, but let's step it up a notch, right? What if you have inequalities? What if you have f of x now is greater than root 2x minus 1? Okay, so we're going to do this. Oh, sorry, 1 second. My brain is on the phone. Okay, so let's pick some points here. Where is the end point for this? X equals what? 1/2. Okay, now, it's x equals 1/2. Now, do you see how this is greater than and not greater than or equal to? If we were graphing something on a number line, that would get an open circle, correct? Yes. So that end point at x equals 1/2 should get an open circle. Let me make this bigger. Okay? Now, we're going to plug in some points here. I'm going to put, let's see, is 1 a good point? Would that give us a perfect square? Yeah. Yep. So I would get the square root of 2 times 1 minus 1, which is 1. What's another number I can pick? 5. I would get the square root of 9, which is 3. So x is 1, y is 1. X is 5, y is 3. Now, this is a greater than, not a greater than or equal to. So we get a dashed line. Remember the dashed lines? Yes, you do.
It's a combination.
Huh? No ruler.
It's not supposed to.
It's not supposed to be. It's an absolute value.
No, but it's like
It's okay, right? So here we go, absolute value. Now we need to shade. So now this is greater than, that means I need to shade above, correct? Now, there is also a boundary at the end point, at x equals 1/2. It can't go past x equals 1/2. So what I like to do is I like to put a little dashed line here, okay? Because the region that's going to be shaded is here. So it's like, you know, all of these points here work, and then, you know, anything that let's say x equals a half, y equals 4, that's not in there, right? Anything on this vertical line isn't included, it's just that. Okay, why don't we do another one? Let's take a look at the next one. So the end point, this goes to the left 2 and down 4. The end point is at -2, -4. Now, is it going to be closed or open circle? Closed circle. Now, for this one, because it's an integer, right? It didn't land on like x equals a half. We could just do like the shortcut. So if I go to the right 1, which way do I go? Down 1. If I go over 4, I go down 2. Okay? Now, solid or dashed? Solid. Okay? And again, this time, this time though, it's a solid line here, right? Because it includes that point. And so all of these are in there. Okay? All right. So why don't you go ahead and take out your calculators.
No, absolutely not.
Okay, let's see if we can graph these on the calculator. So we want to do an inequality. That means, okay, we're on the scratch pad. One quick way to do an inequality is over here, you can just press the delete button once, just once. Don't go delete happy. And you should get this menu. And you have to pick greater than. All right. And we're going to do square root. You all know where the square root is. 2x minus 1. How wonderful is that? Right? Isn't that cool? All right. So why don't we do the next one? Less than or equal to. So remember, if you just erase it, the menu is above the equal sign. Less than or equal to. Whoops, less than or equal to. Negative x plus 2. X plus 2 minus 4. Look at how beautiful that is. Isn't that beautiful? Isn't that the best thing ever? And if you want to see past this point, let's say negative, 15. And look, you could see like a wider range. What? Right? We've now made it. Like we've made it into the big leagues. Okay, yes.